So, starting lecture proper. The first thing I want to talk about is the feedback in Autolab. After you've done lecture objective 1 from Wednesday's class, you should only have this portion. This is the only portion of your feedback that you should see any changes in. These, if you've completed the code for that, what I gave on Wednesday's lecture, you should have 3 smiley faces here, and that's it. Your test suite should look like this because we haven't done any testing yet. So you shouldn't have any testing completed because we haven't talked about that. If you want to read ahead, if you want to go ahead and start writing tests, that's fine. But that's not the expectation. That's fine if you haven't. If you're not looking ahead and doing the testing. We'll talk about testing on Wednesday is when we'll start doing this testing. So Wednesday's lecture objective, this is the only portion that you're working on, getting your smiley faces there. Today's lecture objective, you're only working on these 4 smiley faces. For next Monday's lecture objective, you're only working on these 4 smiley faces as well, only those portions of the objective. Then next Wednesday, when we talk about testing, your lecture objective isn't going to be lecture objective 4, it's going to be to add testing to lecture objectives 1 through 3. So next Wednesday, we're going to do this portion, and this portion. So right now you do actually have a few smiley faces because you have no testing at all. If you have no testing at all, what your testing does is passes everything. So you're just passing everything. What you're testing, once you write it, should pass your own submission and should pass my correct solution. So you're correctly passing those because you're just not doing any checks. You're just saying everything's good with every piece of code I ever see. But you're also passing incorrect solutions, which is not good testing. So you get the sad faces here because you're incorrectly passing some of my incorrect solutions because you're just passing everything. So this is the expected output, which you expect to see in your testing output when you haven't written any tests. Also, way at the bottom, learning objective right and application objectives. And when you submit and see this hand-in history, you should expect to see zeros. You'll see zeros for most of the time. This is something just for psychological reasons I'm realizing is kind of bad. It looks like you're always getting zeros on your assignment, even though you're making a lot of progress. To look at your progress, make sure you're looking at the actual feedback to see how you're progressing through the objectives. But you're going to get 2 zeros for almost the entire time that you're working on this project. Those scores are either 0 or 1. They are strictly nominal. There's no meaning to the actual values of the numbers. It's just, did you complete the learning objective right portion yet? Which is all 5 lecture objectives plus testing plus one of the 2 programming objectives. So that's a lot of work just to get to get this to change at all. And then the application objective. Did you complete the application objective at the end? Which is, of course, a much more difficult objective, in my opinion, at least. Okay, so hopefully that clarifies a lot. T's and I have been getting questions about that pretty extensively over the past few days. So hopefully that clears it up, clears up that confusion. So with that, I didn't download the slides, did I? So the slides are updated. You have to refresh the page if you loaded it before I updated. And I guarantee you'll have, the most recent slides, because as you saw me just there, I download the slides off the website for presentations, for lectures. So you always have access to the slides that I'm lecturing with. I always got zeros anyway. Well, that's also a possibility. You might still get zeros. But as long as you're working on it, you'll get my recovery plan. We'll work with you. You get zeros all semester and technically still pass the class, depending on what goes on in those recovery plans and those meetings. Do I use the Zoom link in Piazza when someone has office hours? Yes, unless they have Discord next to their name in the schedule, then they have office hours in Discord. The T's and I are actually talking about that. And I appreciate any feedback, too, if you prefer Zoom hours or Discord office hours. Okay. 7 minutes in, let's start talking about some content. Start talking about programming. Zoom. Last time I asked, I had 2 answers and they were both Zoom. Discord be nice. You can see the queue. Well, the way we have it set up this semester, you're going to be able to see the queue in Zoom as well. All right. So let's talk more about Scala. We can. I shouldn't have asked that before lecture. I should ask that at the end. But we can talk about. I'll miss a lot of the chat about that. But we can talk about it after, because we got to learn some stuff here. So lecture objective 2 from Pale Blue Dot. This is the lecture objective. By the end of today's lecture, you should be able to do this. By right now, unless you read ahead, you should not be able to do this. So this is what we're gonna show you how to do today. Is lecture objective 2 from Pale Blue Dot. Not the testing though. We're still not talking about testing until next Wednesday. So you'll be able to get where it says, I'm running your code against my test. I forget how I worded it. When I run your code against my test against your code, that part is what you're working on. And then where it says testing your tests, that part you still won't have completed because we haven't talked about testing yet. But the first part of lecture objective 2 of Pale Blue Dot, that's what we're working on for today's lecture. This is what I want you to be able to do. So what are we doing? We're writing a method named getCountryCode, which takes 2 strings. One string is a file name containing country data in this format. It's going to be the name of a country, the hashtag or $, and then a 2-digit code of that country, a 2-digit representation of that country name, and then each line has a separate country and country code. So the entire file follows this format. We want to parse through this file, and given a second parameter, which is the name of a country to look up, we want to return that 2-digit country code for that country. So we want to read through this file, read each line, separate the country name from the country code, check the country name. If it matches our input, we want to return that country code. We do have to worry about some case, upper and lower case for this question. Specifically, the country code needs to be returned in lowercase, and the country name needs to be case insensitive. So your code needs to be able to handle any case that the input is given in. So as you can, so for example, Japan with a capital P or any strange capitalization, mix of uppercase and lowercase letters, as long as the characters exactly match, the letters exactly match what's in the file, that should be considered a match. So Japan, all caps, Japan with a capital P, these should both be considered equivalent to Japan with just a capital J. Those are, for your code, should be exactly the same, and then you should return lowercase j, lowercase p as a string. The country code in the file is always going to be uppercase, and then you need to return it as lowercase. And you should be able to see by now the lecture objective for Wednesday, that was strictly not super strictly, but mostly an exercise in cloning the repo, getting things set up in IntelliJ, and creating a zip and submitting to Autolab. And the code itself was really trivial. The only question is capitalization in math and pi, trying to get that constant correct. This question is much more in depth, and this is where we're very quickly going through a lot of 115 content, but in Scala. So this is moving fast. We're going to ramp you up with Scala very quickly and get you to the point by the end of today that you can do this in Scala. So let's do that. So a lot to talk about to get you there. First, we got to talk about some types. We mentioned on Wednesday that Scala is a strictly typed language or a strongly typed language. So we have to specify the types of every variable. We have to be very aware of what type every variable and every value that's moving through our code is. So let's talk about some of the common types that we'll be using at this point in the course. For starters, we're going to talk about these int long double Boolean unit string. And of note, there are only objects in Scala. Every value in Scala is an object, which is a line that might not mean too much to you right now, but it's something to keep in mind as you learn more about Scala. Every value is an object. If you're familiar with primitive types, Scala has no primitive types. Everything is an object. So let's go through these types and just talk about what each one of these types is, how it behaves, and talk about them in a little bit more depth than you talked about them in 1.15, because you did use these types, or the JavaScript and Python equivalents of these types in 1.15. But let's go a little bit deeper. Not too deep, but a little bit deeper. So an int, this is a whole number. It can be positive or negative, and it has a 32-bit representation. So in the machine, a computer only knows ones and zeros. That's it. So everything that we represent in a machine, we have to figure out how it's represented as ones and zeros. So an int is a 32-bit representation, 32 ones and zeros. 1 bit for the sign, whether it's positive or negative, and then 31 bits for the actual value of this int. So we can range from, so our max value is 2 to the 31 minus 1 is the highest value that we can store, because we have that last bit for the sign. An integer can overflow or even underflow. I'll talk about overflow in my example. But an integer can overflow. It can only represent, since it's 32 bits, can only represent values in this range. So, since it can only represent values in this range, what happens if we go out of that range? Well, if I have an int, and this code is in the examples repo you cloned yesterday, you can run this example and verify that if I have an int that stores the maximum value for an int, and I add 1 to it, it's actually going to wrap around to the minimum value and give you negative 2.2, I should know this off the top of my head, 2.2 billion, right? Yeah, negative 2.2 billion-ish. It will actually wrap around, which is probably, if you have this in your code, probably not the value you actually wanted when you're adding 1 to 2.2 billion-ish. Probably don't want negative. So this is one of the cautionary tales we have for ints. We have to make sure that we don't overflow an int. The unsigned int, we could use, to be honest, I don't know. I don't recall if Scala has an unsigned int. Yeah, it must. I would assume it does somewhere. But you can use an unsigned int, and then you can go 0 to 4.2 billion. You can get that 1 extra bit because you don't have to use it for the sign, but it's not getting you much further. Our class's objects is actually a pretty deep question when it comes to Scala. I believe they are underneath the hood, like their actual representation. For our context in 1.16, we use classes to create objects. We can never have a class. We can't really have a class as a value in our program, but we can use classes to create objects and treat those objects, have those objects stored as values. But to have a variable or value that stores a class, you can do that, but at that point I believe the class is stored as an object that stores the contents of the class, technically under the hood. All right, so that's int. If we want a bigger integer value, we can use long. It's the same thing as an int, except a 64-bit representation. So 63 bits for the number, 1 bit for the sign, and we have a much larger range. And if we have that same case that would overflow an int, no problem with the long. We don't have a problem with overflowing until we hit this number, which is quite large. There are actually other classes, big integer, that you can use if you expect to overflow a long, which I've had cases where I expected to go beyond this. But for our purposes, I'll actually use int throughout the whole course until very specific cases where I do expect an int to overflow. And you'll see me just in one case in this class that I'll have to pull out a long because I expect the values to overflow an int. It's when we store the epoch time as nanoseconds. I expect that to overflow an int. You could use long for a safe bet, except I won't really let you in this course just because most of my objectives are going to say write a method that returns an int or write a method that takes an int. But in your own code, if you want to use long instead of int to play it safe, go for it. Ints and longs are both subject to integer division. If you divide 2 ints or 2 longs or a mix thereof, you're going to get a result that is an integer or a long. So if I have 2 ints and I divide them, the result will always be an int. So if I don't specify my type here, Scala is going to infer that that's an int because this division is going to return an int. I have an int. When I print that out, it will be an int, which means we cannot have decimal places when we divide 2 integers. So this does not divide evenly. I should have some decimal portion here. What happens with integer division when you divide two integers is the decimal portion is just flat out deleted. It's just ignored. It's removed completely. So we're effectively returning the floor of the division. So we divide and then take the floor of the resulting quotient, and that's what's returned. So this is something to be very aware of. You will run into this. I get this question in office hours, even with this slide, fairly often. And if you come to office hours with me, hey, you'll learn something. I'll get to remind you, remember integer division. You'll be like, yeah, integer division. So integer division, this is something that will come up. You will have to be aware of this in your programs. Which brings us to double. Double can have decimal portions, and it's a 64-bit representation. Somebody mentioned float in chat. Again, I don't... I should know this stuff off the top of my head, but I always use doubles. I don't know if Scala has a float, but if it does have a float is usually a 32-bit representation, a floating point representation. Unless you're in Python, then a float is a 64-bit representation. It's all over the place, but double we will use when we need floating point numbers, when we need decimal portions. This is a 64-bit representation. And there are certain decimals that we cannot fit in this. So we will have truncation to make sure that a value can fit in a 64 bits of memory. And we won't get too far into the details here. You will take courses that will go into the IEEE representation of a double. But just really quick, we have 1 bit for the sign, 11 bits for the exponent, and 52 bits for the number itself. And the way these doubles are stored is like scientific notation. We have the fraction portion, which is the number, with only one leading value. And it's mostly the decimal portion, and then the exponent, which is like times 2 to the exponent. So it's scientific notation, but in binary. So that's how we're storing the doubles, plus the sign, of course. So whatever we can fit in this representation, that's what we can represent. But we can't fit everything in this representation. So, for example, let me explain just a little bit about binary representation. I will assume that you understand binary representation for integers, but we can do the same thing with decimals. Decimals go the same way, follow the same theory as base 10, where in base 10 you would have the tens digit, the hundredths digit, the thousandths digit. It's the same thing in base 2, but divided by 2 each time. So we have the 1/2 digit, the 1/4 digit, the 1/8 digit, and so on. And that's how we can represent fractions, I guess, and decimals in non-integers in binary. That's how they're represented. So there are certain values in base 10 that we can't store. So, for example, 1/3, we can't represent this number exactly as a decimal in base 10. So if we have the fraction 1/3, that's 1.3333 repeating. We'd have to store 3's forever. Eventually, we're going to run out of storage in the universe, and we can't store that number exactly. The same thing is true in base 2. If we have the number 0.1 in base 10, this is nice, clean, 1/10. We can store that in base 10, no problem at all. And I hope all of you are familiar with, 0.1, that's 1/10 of a whole number. But we can't represent this in base 2. So 0.1 in base 10, or 1/10, is not equal to what this value is. This is an estimation, but to represent 0.1, it's 0 halves, 0 quarters, 0 eighths, 1/16, 1/32, 0 64ths, 0 1/28, 1 2/56, so on and so forth. And then this 0011 repeats forever until we run out of space in the universe. We just can't exactly represent 0.1 base 10 as the sum of fractions of powers of 2. We just can't represent that exactly, the same way we can't represent 1/3 as fractions of powers of 10. So at some point, we just have to truncate this. If we're storing this in a double, we're going to use as many bits as we have available in our 64-bit representation, and then just cut off the rest and estimate it. So we just do our best when it comes to storing these values. So what does this... your Scala hurts your head already? This isn't even Scala quite yet. I mean, I guess it is, but this is stuff you've been working with all along in 115. I'm just explaining a little more detail about how the computer works. How do your programs execute is our big umbrella right now. How do your programs execute? This is part of how your computer is executing and handling numbers. So in code, the value 0.3 is not, or 0.1 is not represented exactly. So if I have a double and I store 0.1, and you can run this example, you can verify, you'll get this exact result. If I have a value 0.1 stored in a variable, and I say, if you just print it out, it'll actually print out as 0.1 for what it's worth. But if you start computing with it, for example, if you multiply it by 3, you're not actually going to get 0.3. You're going to get something very, very close to 0.3. But since that has some repeating value that had to be truncated to fit in 64 bits, we actually don't get 0.3 exactly. We get something very, very, very close to 0.3. But very importantly, if I have a conditional after this and I say if C equals 0.3, that's false. And that's where it really matters to us as developers. That's where we really have to internalize what's happening here and realizing that we cannot use equality with doubles because of these truncation errors. We're going to get all kinds of issues because of these truncation errors. So when we do want to compare doubles, which we'll do in our testing when we want to test, does this method that returns a double return a value that I expect? We don't use equal for that because this is going to result in false. C does not equal 0.3. For our purposes, it should. To the computer, it does not. These are not equivalent. So what we usually do is have some very small value, and when we compare two doubles, we're going to say, is the difference between those two values less than some very small value, which we typically call epsilon, at least in math circles, small values are usually called epsilon. So is that the difference between those two values less than some small value, which is small enough to not affect our computation, but large enough to compensate for any truncation errors, which will be very small. So you can play around depending on your application, which exact value of epsilon you want. I usually go 3 or 4 zeros out, just to make sure that we're not getting bit by truncation errors when we're comparing doubles for what would be equality. Boolean and unit. Boolean is what you expect, true or false. I don't really have much to say about that. And unit is a placeholder for nothing. Means this method, we use this for return values if a method doesn't return anything. If it doesn't return a double, doesn't return a string, doesn't return a list, we're just going to say it returns unit and say to tell Scala, I don't expect this thing to return anything. Don't return anything. The last expression that's evaluated in this method, don't bother returning that. Just don't return anything. We've seen two methods already that return unit, main and printline, both return unit. We don't call printline for return value. We call printline for what we call its side effects, which in that case is printing to the console so we can read what's happening. A unit is essentially none in Python or void from Scala. And before we talk about strings, I feel like these lectures go a million miles an hour, so let's calm down for a second and see if you have any questions. Why is it called unit rather than void? I don't know. That's just what they felt like. There is also a void, I believe. Well, since we're taking a quick break, I can pull up IntelliJ. I don't have IntelliJ run. Oh, that's right. My Windows had updated and closed everything. So I'll boot up IntelliJ. I believe Scala has a void, though. Yeah, well, it just uses Java's void. So we can still use void, but Scala has its own unit. So we're going to use unit. It's just the Scala way. Oh, Scala confuses you? We'll get you through it. It'll take time. Like, Scala comes by really quick in this class. We'll get you through it. If it's confusing at first, we got time. Why doesn't IntelliJ say error? I mean, It's not something I can answer during lecture. You can come to office hours. We'll help you out with that one. Hopefully you went to lab if you came across that in the examples repo. However, we helped you fix it in lab yesterday. It's going to be the same answer. All right, so let's keep chugging along. Let's talk about strings. Strings are very important for your lecture objective today, so we better be talking about some strings. So strings are a sequence of characters, and as they are in most languages. So strings are a bunch of characters, which is a type char, which I don't think comes up in this semester. If you see me use char, I'll explain it as it comes up. But char is a single character, just one single character, where a string is a sequence of these characters to form, words and anything that we can represent as a sequence of characters. They have to be declared with double quotes. So coming from Python and JavaScript, where you could use either double quotes or single quotes. We don't get that feature here. We don't get that functionality. Double quotes only. If you want to represent a string that contains a double quote, use a backslash, which is the escape character, backslash, and then double quote. And that's going to escape that. So instead of saying this is the end of the string, it's going to say, no, put an actual double quote in the string itself. Where in the other languages, you want a double quote in it, you just wrap it in single quotes, and it's fine. We also have a lot of methods that are useful with strings. I won't go through. Actually, we do have examples coming up with a couple of these, but there are lots of methods with strings. I link to Split, I believe, directly from the course website. But that page that contains Split also contains all of the methods in the string class. There's tons of functionality in there, tons of things you can do with strings to be able to manipulate strings, parse them, create substrings of strings. And I'll leave that a lot up to you to look through there and look for the methods that will be helpful for you as you're working on your programming assignments. The ones that you strictly need, especially for like today's lecture objective, I'll explain and show you. But there's a lot more in there that, there's tens of methods, at least, maybe 50, I don't know how many. But there's a lot of methods in there. A lot of them are very useful. A couple I'll highlight here. Starts with. If you have a string, you can call a dot, like if I say s dot starts with, and then some other string, it's going to check literally if that string starts with those words. So if I say s dot starts with valid, that's going to return true because that string does start with the string valid. So a handy string to see if a string starts with another string. I like this. For those of you looking ahead at Pale Blue Dot, the cities file has a header line that you need to ignore when you're parsing the file. I like to ignore that by saying if line starts with the first little chunk of that header line, then ignore it. It's a nice quick way to get rid of the header line in a CSV file. Length, how many characters are contained in the string, and split. This is going to be very important for us. The string.split method is going to take a string and create an array of strings. Create an array of strings containing all of the strings separated by the string that you give it, which if you haven't used split, the way that sentence came out probably didn't make any sense at all. But if you've used split, which you should have in 1.15, unless you only use the CSV parser, which they may be teaching these days, but it doesn't matter because my next example is going to use .split. So we're gonna look at it. This is a very useful, for my purposes, this is probably the most used method that I have. And a few, actually, now that I think about it, I should add to the slide. .2 lowercase and .2 uppercase are going to be very important for your lecture question. Convert a string to all uppercase letters or all lowercase letters, respectively, are going to be important. I can show examples of that after these slides. So we have all these types: int, long, Boolean, double, string. We can sometimes we have one type and we want to convert it to another type. To do that, Scala has a lot of methods in these classes, in these objects, that are to and then whatever type we want to convert to. So for this example, we create an int, a double, a Boolean, and a string. This string happens to be a well-formatted double. So we can take that string and just slap a 2 double on it. And that's going to Scala's going to do its best to convert that string into a double. Since this is a well-formed double, something that can be represented as a double, this is going to return a double, and we can store that and then treat it as a double. For your cities file, when you get to those objectives, there are latitude, longitude, and population represented as 2 doubles and an int. To convert those strings into doubles and ints, 2 double, 2 int, those are going to do the trick for you. And then everything has a 2 string as well to convert anything to a string. Yeah, so sometimes like if I added the parentheses here, I believe that would actually cause an error. In these cases, sometimes Scala wants the strings. It depends how the method is defined. Sometimes Scala wants the parentheses. Sometimes it doesn't. But I believe this one is an error. Yeah, this one is an error. And sometimes it's optional, just depending on how the developers wrote the method. For the methods we write, in most cases, we're going to use the parentheses. Can you not print doubles? No, you can print doubles. So whenever you use printline will implicitly call toString on whatever you give it. So you don't have to do any conversions there, any type conversions. Let's talk about loops. All right, the syntax, I assume you're all familiar with loops. The syntax for a loop is like Python, and most of the loops you've seen in JavaScript, where they're always what we call for each loops. We're always iterating over a data structure. So the syntax for this is for some variable name of your choice. This is read as in, and Scala, I'll warn you right now, Scala developers, they love their arrows. So there's a lot of different types of arrows in Scala. This one, the less than sign and then a dash. This is an arrow which is read as in, and you can kind of visualize we're pulling information from this data structure that we're iterating over, pulling that information into this variable name, and then running the body of this loop. And this is read as for variable name in data structure, execute the body of this loop. So it's just like a for in loop or a for of loop in Python or JavaScript. And again, I assume you know what a loop is, so we're talking about just the syntax. And if you want to use these loops like you would a Python loop, where you're just iterating over some numbers, we can use this to method. So the to method, if we do for some variable name, I just called it I here, in a data structure containing the values 1 to some value n. And if I write this in a method, and of course we're going to start combining these, dropping this class now, bad boy. So I call this method print 1 to, print 1 to 10. This n is going to be 10. For I in 1 to 10 is going to print the values 1 to 10, since I'm just printing in this example. Just to expand this a little bit and get some of the mystery out of this to method, this is actually a method call which is going to return a data structure containing the values 1 to n. And the type of that data structure is actually a range, and then we're iterating over that data structure for variable name, whatever I name, in this data structure, which happens to be exactly a range, a data structure of type range. Iterate over those and execute this code. Yeah, I think he forgot he was pretending his keyboard was broken. You can't use the C JavaScript Java syntax in Scala. Like with the semicolons and the 3 statements. Not allowed. Got to iterate over a data structure. All right, so let's see a little bit bigger example, and let's start continuing to combine these concepts. And I warn you that this content does go fast. Again, I assume you understand the concepts. I just want to go over the Scala syntax of how to do these things in Scala specifically. And these slides, this video especially might be one you want to rewatch. Go over the slides, go through the examples repo that we cloned yesterday. Look at these examples, play around with them, change them, tinker with them. It'll take you a while to get the syntax, but it's really not something that I can cover in lecture. I can't just keep saying the arrow means in for loop. It's something you really just got to take some time. Take some of them 7 hours outside of class and study. So let's see a bigger example. For this example, I want to write a method that takes a string that's formatted as string, but Boolean values that are separated by semicolons, and I want to return the percentage of those values that are true. So just a toy example, not something you do in the real world, unless you have a really specific application, but it combines a lot of the topics that we're talking about. We got a loop, we got a conditional, we got type conversions, we got string splitting, we got a lot of good stuff going on here. So to run this, we're going to create a main method, which is the start of our program. We're going to create a test string, call our method on that string, and then just print out the result of what the result was for this input. So when we have this test string, let's go through this code one at a time and just see what's happening throughout this execution. So the first thing that we do is split the string on a delimiter. So that dot split method that we said earlier that I had that really confusing sentence for we're going to call that method. We're going to use that method to split this string on semicolons, and that's going to give us an array, which we're going to treat as a data structure with iteration. It's going to give us an array of all the separated values with these semicolons being the delimiter. So when I call line.split on semicolon, this array is going to store true, false, true, false, false. So it's going to have 5 values in it in indices 0 to 4 that are going to be stored in that array without the semicolons. We'll talk about the comparison between arrays and lists. Most of the class will use list, but the split method returns an array, so we do have to use an array for this one application. So we're going to split this on some delimiter and get all the parts of that string that are separated by that delimiter. We're going to initialize a few variables and iterate over the splits of this string. So for each of these values, starting with true, the value true is in the splits, assign that to value, and then execute the body of this loop with that value true, and then the value false, and then the value true, 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 and then end the loop. So we're going to iterate over this data structure. Jesse's going too fast for our small brains. Oh no. I know this is a lot, but this is 115 content. There's nothing new but syntax here. You should be able to follow this based on your 115 knowledge. I am banking on that a lot. I warned you day one, you got to understand the concepts of 115 or else this class is going to run you over. If you don't understand all of 115, if you couldn't get an A 100% on the final exam of 115 right now, you are behind. You got to start studying. You got to catch up. You're already behind. Because I assume that you know 115. That's why that's a prereq to this course. It's a very simple concept, but so many students don't take the 115 final and then flush all that information out of their brain and expect to do well in 116. It does not. It can't work like that. Would you expect to do well in Calc 2 if you didn't know Calc 1? Same thing. So we're going to iterate over those splits one at a time, and we're going to execute the body of this loop. The first thing we're going to do with each value is convert it to a Boolean. This isn't strictly necessary. I just want to show off the toBoolean method. So we're going to take that value, convert it to a Boolean value. So when it's true, Scala is going to be able to convert that to the Boolean value true instead of the string true. We're going to store that in this value, and we're going to say if that's true, we're going to update the count of number of true values that we found. And whether that's true or not, we're going to update the total count that we found, the number of values that we iterated over. Again, there are cleaner ways to do this, but I want to show off a conditional, so I use the conditional to do this. And then we're going to divide the two to get the percentage, or at least the rate, of trues that we found in this string that we split, and return that value. Now note, I did create these as doubles, even though they're storing strictly integer values. I created them as doubles, so they're stored as doubles. So when I get to this division is not integer division. So since they're doubles, I'm actually going to maintain the decimal portion of this division, of this quotient. And one more quick example, since it's relevant to your lecture objective. If I have a string that I want to split, I'm going to take this string, split it on underscores, and store it in an array. If I want to get each value independently from a single split of a string, we use parentheses and then the index number to be able to access those values. So if I want value 1, I'm going to get the value at index 0 using splits, the array of 0, the array of 1, get the value at index 1, which is going to be this after the split. At index 2 is going to be value 3 after the split. This will print out value 1, value 2, value 3. So that's going to be important for your lecture objective, so you can get the name of the country and the country code separately in two different variables. Can you divide integers and convert them to doubles while dividing? Yeah, so one quick shortcut way to do that, if I had true count and total count both as ints, if I did true count times 1.0 or true count dot to double, that would also do the trick for me. That would do the same thing. As long as one of the values is a double, the quotient is going to be a double. But if both are integers, that's when we get integer division. So if we convert one of the two into a double, then we're good. Or I just store them in doubles here, then I know we're good. Can you upload some documents for Scala syntax in order to catch up fast? I link to a lot of documentation in the course schedule. Check out the course website. It's got everything you need. And all the examples I'm showing are in that repo we cloned yesterday. I don't know what more I can make accessible without completely overwhelming you. Some of you are overwhelmed just watching lecture, much less more resources. What do we made Physics Engine? Physics Engine I did yesterday. The other section is still doing Physics Engine. What's up, Trino? All right, one more example because we haven't talked about reading files. Luckily, reading files is pretty straightforward. I think, I'm sure some of you might disagree, but I think that it's pretty simple in Scala compared to certain other languages, at least. Okay, and last example, and then we can take a breather and go into the chat. Imagine being on campus and learning. So to read a file, here's an example that doesn't really do anything useful anyway, but it does show off reading a file and how we can read a file line by line. So the first thing that we're going to need is we're going to use our first class, or our first object that is not automatically imported. So everything we've been using so far, strings, arrays, unit, math, all those are automatically imported and available in any Scala program without explicitly importing. Source is the first one we're going to use that's not auto-imported, so we do have to have an explicit import statement to tell Scala, hey, I want to use the source object. I want to use the methods that are contained in it, so I'm going to import it. If you type out this line, oh, and damn it, I didn't update this. I have to import buffered source as well, the way I have this structured. In the examples repo, it's buffered source is imported as well. So if you pull this up in your examples repo, in the package example.filereader.scala, that does have buffered source imported as well. That does need to be there. If you're cut and pasting from the slide, this isn't going to work. Just a heads up, because you need that extra import. But if you just type out this line, IntelliJ is pretty good about imports. I don't think I rarely explicitly type an import statement. Scala will be like, hey, you typed source. You want me to import scala.io.source for you? And then you go like, yeah, I want you to do that. And then you don't have to think about it. to use the source object, which it has a method named fromFile, which takes a name of a file as a string and returns a buffered source with the contents of that file. And this is the majority of our file I/O in Scala. Source.fromFile, that opens the file as a string. It takes a string and opens the file with that file name and gives us a buffered source that we can iterate over by using .getLines. The buffered source has a getLines method, which is going to give us a data structure, or at least an iterable, that will iterate over each line of the file. It'll read each line of the file, give us the contents of that line in a variable, and we can iterate through each line and store each line in this variable one at a time, then execute whatever we want to execute on that line of the file. And for what it's worth, in Python, when you iterate over lines of a file, the line will have that trailing new line character at the end. Scala will not have that. So just for those of you who ran into issues with that last semester, this line will only be the contents, not the new line character at the end. And here I'm just concatenating all the contents into a single string. This isn't something you want to do, especially when you're reading large files. So if you're reading the cities file, which is tens of thousands, I forget, it's a big file. If you're cut and pasting this code and then reading the cities file, your program's going to run for a long time. It's going to take a long time because this is very inefficient to concatenate the contents of a file into a string line by line like this. Typically what we do is inside the loop, do any processing that you need to do on each line of the file, and don't worry about storing it in just a single string like this. That'd be silly to actually do this. I'm just doing this for a lecture example. I felt like I should have had something in the body of the loop. Maybe I could have just put a comment that said, this is where your code will go. But the big part is source.fromFile and getLines. And you can even do this in one line. You could do line in source.fromFile of filename.getLines and then not worry about the buffered source at all with storing that in a variable. I do actually want to do that very, very quickly. Just because there's an important point for testing here. So I have these countries and cities are the two files that you'll read for pale blue dot. When you read a file, and I gave an example of this. When you read a file, the path to the file is relative to the root path of the project. So whenever you give a path to a file, it's starting at this directory, not your src directory, which I've seen that mistake a lot. It starts at the root directory. So when I have this file countries, which is in data countries, the full path to that file, or relative path in the terms of this project, is going to be data/countries.txt to read this file. If I just do countries.txt, my program's not going to find the right file. It's not going to find that file at all. Which brings us back to the lecture question. So for this lecture question, you have a file name, sources.fromFile.getLines. Oh my. Iterate over the lines of this file. For each line, you want to check if the first value of that line before the hashtag is the country that you're looking up. To ignore case, the easiest way to do this is to call to lowercase on both strings that you're comparing. So you want to ignore this case, ignore this case, ignore this case. Just call to lowercase on everything, and no matter what the case was, it's all going to be lowercase, and then you can use equality. If these two strings, after converting them to all lowercase, are equal, then I'm going to treat them as equal. And then if they're equal, we want to store the country code in a variable that we're going to return after the loop. And we want to make sure we call to lowercase on that as well to make it all lowercase. Iterate over the file, split the string on hashtag, compare this with the input to lowercase. If they're equivalent, store the country code to lowercase, And then after the loop executes, return that value. What do I mean by 2 lowercase? So if I have a string, let me grab a string. String equals some mix of uppercase and lowercase. String, I can't even type today. If I want to convert that to lowercase, And if I run this, oh my goodness. Bear with me on this. Jeez, I'll get there. And then when I run this, this is going to print this string, but with all lowercase letters. This helloed. For some reason, that's what I ended up typing. And once this compiles and runs, oh, yeah, hold on. Wait, what did I even do? We get that string in all lowercase letters. So if I want to check if these two strings are equivalent, maybe this has a capital H at the beginning, like you'll see for the country names. I'm just going to print line s dot. I'm just going to print it so you can see. You wouldn't print this to the screen typically. Equals s2 dot 2 lowercase. I can effectively compare if these two strings are equivalent while ignoring case. So this is a case sensitive comparison and I get true.